bases are sometimes represented in equation form. Such equations are referred to as exponential equations. Hello everyone, this is our junior certificate mathematics lesson. My name is Raiwane Gare and I'm with a learner from the Tajani Junior Secondary School with the name Unalenna, who will be helping me in today's discussion. Let us have a look at the lesson objectives, because the objectives guides us what we will discuss. The lesson objectives: solving exponential equations. So this simply means we are going to be solving these exponential equations. We'll just be solving them. But before this, what is an exponential equation? It says an exponential equation is an equation in which the variable you are solving for is an exponent. That is the equation where the variable you are solving for is an exponent. For an example, if you have 2, this is supposed to be 2. If you have 2 to the power x, it's equals to 16. This is an exponential equation because the variable you are solving for is an exponent. It's a power. So you are solving for the exponent, in this case x. So this is an exponential equation. Now, let me invite Unalenna here to chip in our discussion today.
Good day, I'm Onalin. The concepts we've just discussed appear not difficult but challenging. Can you please elaborate it by means of examples?
Thank you, Unalenna. You are saying how do we solve exponential equations? I'm going to present examples of exponential equations and in the process solve them. The exponential equation we are having here is 2 to the power m equals to 32. But you should understand the basic idea behind solving exponential equations. The idea behind solving exponential equations is you are to make sure that the bases on both sides of the equal sign are the same. Then that's when you can solve. For instance, if you have x to the power a equals to x to the power b, then we can see that here the base is x on this side, and then on this side also, your right hand side, your base is x. So if x equals to x, then this will mean a will be equals to b. So this is the idea behind solving exponential equations. But then let us go into the task. It says you are to solve the exponential equation 2 to the power m, it's equals to 32. 2 to the power m, it's equals to 32. The variable is m, so you are to solve for the variable m. And like I said, the idea behind this exponential equation is to have the basis on both sides to be the same. Then by doing so, you'll have solved. So we've got m 2 to the power m, and on this side we've got 32. This simply says we are to write 32 using base 2, because on this side we got 2. So we have to write 32 using base 2. And this will be 2 to the power m, it's equals to 2 to the power 5. 2 to the power 5, you can check. 2 times 2, that is 4 times 2, 8 times 2, 16. 16 times 2 is 32. So we can write 32 using base 2. And when we write 32 using base 2, we get 2 to the power 5. So what we are simply saying here is 2 is equals to 2. Now, if 2 is equals to 2, this simply means m will be equals to 5. So we have solved for the variable m. Our m is equals to 5. And the idea behind this is simply to make sure that you've got the same basis on either side of the equal sign. Then by doing so, you'll be able to find what your exponent in the case of a variable here will be. So here our m is 5. And then let us have a look at another example. Another example is this. 6 to the power y is equals to 36. So on this side we got 6, this side is 36. So we are saying every time you are to make sure that the bases on either side of the equal sign are the same. So this will be 6 to the power y. It's equals to, you have to write 36 using base 6 because you are guided by this now, 6 here. So write 36 using base 6. And upon writing 36 using base 6, you will get 6 to the power 2. When you multiply 6 2 times, you get 36. So it's 6 to the power 2, meaning y is equals to 2. We have solved for the variable y. So y is equals to 2. Let us have a look at the last one in this part here. Example, 9 times 2 to the power e is equals to 144. It appears a bit complex, but with some simple arithmetics, you'll be able to find what the value of e is. So here, we have to start by dividing by 9 on both sides. Divide by 9. 144 divided by 9. You can get a calculator and then divide 144 by 9. 144, not 44, but 144. 144 divided by 9. It's 16. So 144 divided by 9 is 16. So this simply means on this side, 9 cancels 9, this 9 cancels this, and then 9 here once, 9 into 144, 16. So you got 2 to the power e, it's equals to 16. Because upon dividing 144 by 9, we got 16. So this simply saying 2 to the power e equals to 16. So you have to write 16 using base 2. Write 16 using base 2 so that on both sides of the equal sign we got the same basis, because the idea behind this is to make sure that the bases are the same on either side of the equal sign. So this will be 2 to the power e, it's equals to 2 to the power 4. 2 times 2 is 4 times 2 it's 8 times 2 is 16. So we multiply 2 4 times to get 16. So this is 2 to the power e is equals to 2 to the power 4. And then here our e will be equals to 4. E is equals to 4. 2 is equals to 2. Therefore, e is equals to 4. This is how we solve exponential equations. And I want to believe you have understood this. Let us go for a quick break. When we come back, we'll continue with our lesson. Welcome back from the short break. We are still discussing exponential equations, and I'm still with the learner here, Unalenna, who is helping me in today's discussion. And I want to give this chance to ask another question with regard to this topic.
There are some exponential equations in which the base is in the form of a fraction. How do you solve those equations?
Let us have a look at this example and then work it out. The example is 1 over 7 all raised to the power r. It's equals to 1 over 49. So this is a fraction. 1 over 7 is a fraction, and then raised to the power r is equals to 1 over 49. Remember, the idea behind solving exponential equations is to make sure that you got the same basis on either side of the equal sign. That's when you'll be able to solve. So here we've got 1 over 7 raised to the power r. But then on this side is 1 over 49. So this is simply prompting us to say, write 1 over 49 as 1 over 7. And then how do we do that? It's simple. 1 over 7 raised to the power r, it's equals to 1 over 7 squared. 49 is 7 squared. So we can write 49 using base 7, and that will be 7 squared. This then will be 1 over 7 all squared. Remember, 1 squared is 1. So this one is the same as 1 squared. And then this will simplify to 1 over 7 all raised to the power 2. So what will be the value of r? 1 over 7 raised to the power r, it's equals to 1 over 7 raised to the power 2. So 1 over 7 is equals to 1 over 7. Therefore, r will be equals to 2. This is the value of r. You are simply to make sure that the bases on either side of the equal sign are the same. Then from there, you will now be able to say this variable is equals to this numerical value. Like we did here, we wrote 49 using base 7, and then that gave us 7. So we got 1 over 7 raised to the power r is equals to 1 over 7 raised to the power 2. 1 over 7 is equals to 1 over 7. Therefore, r will be equals to 2. That's how we solve an exponential equation in which the base is a fraction. Let us have a look at another example. Another example is this. 2 over 3 raised to the power x is equals to 16 over 81. So, remember, we are saying every time before you can start solving, make sure that the bases on either side of the equal sign are the same. So this simply means we are to write 16 using base 2 and write 81 using base 3. So this will be 2 over 3 all raised to the power x. It's equals to 16 using base 2. It's 2 to the power 4. It's 2 to the power 4. 2 times 2 is 4 times 2 is 8 times 2 is 16. So when we write 16 using base 2, it will be 2 to the power 4 divided by 81. But then we are to write this 81 using base 3. So it will be 3 to the power 3 times 3 is 9 times 3 is 27 times 3, that will give you 81. So this is 3 to the power 4. We multiply 3 4 times to get 81. And then we have achieved the principle which says make sure that the bases on either side of the equal sign are the same. So this will be 2 over 3 raised to the power x is equals to 2 over 3 raised to the power 4. We can now introduce the brackets here because we can see that this is 2 to the power 4 divided by 3 to the power 4. So the 2 here is raised to the power 4, 3 is raised to the power 4. So the two numbers 3 and 4 are raised to the same power. So we can introduce the bracket and say 2 over 3 all raised to the power 4. So what we have here, 2 over 3 is equals to 2 over 3. Therefore, x will be equals to 4. Our x is equals to 4. This is how we solve exponential equations. Make sure that the bases on either side of the equal sign are the same. Then, by doing so, the job is half done. Let us have a look at the last example under this component. 5 over 2 raised to the power t is equals to 25 over 4. 5 over 2 raised to the power t is equals to 25 over 4. We are to solve for the variable t. So how do we solve for the variable t? Write 25 over 4 using base 5 over 2. So this will be 5 divided by 2 all raised to the power t. It's equals to, we are to write 25 using base 5. So this will be 5 to the power 2 divided by, write 4 using base 2. So this will be 2 to the power 2. And then we can now introduce the brackets. This will be 5 divided by 2 raised to the power t. It's equals to 5 over 2 raised to the power 2. We can introduce the brackets because the number 5 and 2 are raised to the same power. In this case, they are raised to the power 2. So we can introduce the brackets and say 5 over 2 all raised to the power 2. And then when we check, 5 over 2 is the same as 5 over 2. Therefore, t is equals to 2. This is the value of t. We have solved this exponential equation. Remember, The idea behind solving exponential equation is to make sure that the bases on either side of the equal sign are the same. That's how you solve exponential equations. Then from there, you'll compare the bases. Here, 5 over 2 is the same as 5 over 2. Therefore, t is equals to 2. T is equals to 2. The power on this side will be equals to the power on the other side. That's how we solve exponential equations. Let us go for a short break. When we come back, we'll continue with our lesson. Welcome back from the short break. Remember, we are discussing exponential equations. Now, let me give Unalena another chance to ask a question so that we can continue with our discussion.
They appear to be friendly to work with. I, however, want to know about solving exponential equations involving negative index. How do we solve them?
Before we can tackle the example, let us have a look at the general rule which says 1 over a is the same as a to the power negative half. That is, when we have 1 over 3, this is the same as 3 to the power negative 1. So this is the rule that you should know. The negative sign is simply saying the number here is supposed to be below the division sign. So note this. Then we can move on to the example. 3 to the power negative x equals to 1 over 27. The power here is negative. So we are to solve for the variable x, not negative x, but the variable x. Now, we have to write this 3 to the power negative x as a positive index. This will be 1 over 3 to the power x. The implication of the negative power simply says the 3 here is supposed to be below the division sign. So this will be 1 over 3 to the power x. It's equals to 1 over 27. So this is how we simplify this. Then this will be 1 over 3 to the power x. It's equals to 1 over, we've got 27 here. You are to write 27 using base 3. We have to make sure that we achieve a situation whereby the bases on either side of the equal sign are the same. So we are to write 27 using base 3. And then 27 using base 3 is 3 to the power 3. So 1 is equals to 1. Therefore, if 1 equals to 1 as our numerators there, then 3 to the power x will be equals to 3 to the power 3. So if 3 equals to 3, then the powers should also be the same. Therefore, x is equals to 3. This is how we solve an exponential equation in which the power is a negative. The negative power simply says here the 3 is supposed to be below the division sign, and you maintain the value, the variable x. So this will be 1 over 3 to the power x. The negative sign is simply saying 3 supposed to be below the division sign. That's the implication of the negative power. Let us have a look at another example. Another example is this. 3 over 2 all raised to the power negative r is equals to 8 over 27. So here 3 and 2 are raised to the power negative r. And then we are saying all this will give you 8 over 27. So how do we simplify this? This will be 2 over 3 all raised to the power r. The negative sign here is saying the 2 is supposed to be up and then 3 below division sign. Then you raise that to the power r. That is the implication of the negative sign. It simply says 2 below division sign and then 3 above the division sign. So this will be 2 over 3 all raised to the power r will be equals to 8 over 27. Don't write r 2 over 3 raised to the power negative half, because you have taken this 3 below division sign and then 2 up. So you have catered for the negative sign. Therefore, you can now go in and solve. That's the implication of the negative sign. Simply says 3 below, 2 up. Then raise this to the power r. So we have simplified this. Now, 2 over 3, all this raised to the power r will be equals to, it's now simplified. We have touched such examples before. So you can now write 8, this 8 using base 2. And then 8 using base 2 is 2 to the power 3 divided by, and then what about 27 using base 3? It's 3 to the power 3. This is how we simplify it. Then this will be 2 divided by 3. All this raised to the power r, it's equals to 2 over 3. Then we can introduce the brackets, because this is 2 to the power 3 and then 3 to the power 3. So the numerical values 2 and 3 are raised to the same power. Therefore, we can introduce the bracket and say whatever is inside the bracket here is raised to the power 3. This simplifies to 2 over 3, it's equals to 2 over 3. Therefore, the powers r will be equals to 3. This is how we solve exponential equations in which the power is a negative. You simply need to make sure that you cater for the negative power. We have come to the end of today's lesson, but before we part, let us have a look at what we did today. We were solving exponential equations, and I gave some examples of exponential equations where I said an equation like 2 to the power x is equals to 16, it's an exponential equation. And then the idea behind solving these exponential equations is to make sure that the bases on either side of the equal sign are the same. So if you are given 16 here, you have to write this 16 using base 2. Then from there, you compare the powers because the bases will be the same. And then we touched on situations where the power is a negative. And we said the implication of the negative power is to say, make sure that you take the number either below division sign or above the division sign. Then you'll have achieved, or rather you'll have catered for the negative sign for your power. Then from there you compare the bases. Make sure that the basis on the right hand side is equal to the basis on the left hand side. Then if the bases are the same, the powers will also be the same. That's how we solve exponential equations, and I believe you have enjoyed today's lesson. Till we meet again in the next lesson, bye bye.